Okay, in the last video, we introduced the side-angle-side congruence theorem, and we talked about where it comes from and some reasoning behind it. We didn't really prove it. It's kind of one of those things where it's like, is it a theorem? Is it a postulate? How obvious do we need to be? It seems pretty obvious that it's kind of, I think it's kind of more of a postulate, and some books will call it a postulate. But we're going to use it now. That's the big thing. We're going to actually start using it. So this is the theorem again, and you can look this up on page 602. But if two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the two triangles are congruent. Okay, now here is the key, and I even italicized it for you for emphasis. Included angle means it's like in between the two sides, or in other words, the two congruent sides form that angle. Okay, so let's take a look and see what's going on here. Notice in this one we have two triangles. The idea in this is to see if we can say that they're congruent by SAS, and if they're not, then we say there's not enough information. So if we look at this, we have this side congruent to this side, okay, and this side congruent to this side, cool, and this angle congruent to this angle. Is that enough information to say that these two triangles are congruent? Well, here, notice that this is the included angle for these two sides. In this triangle, this angle is in a different position. It's not the included angle for these two sides. Okay, so it has to be two sides and an included angle for both triangles in order to say that these triangles are congruent. Okay, this doesn't match the setup that I showed you in the last video with that reasoning of saying there's only one way to complete this triangle. So in this case, there is not enough information. It kind of looks like we should be able to say, oh yeah, side angle side, there's two sides and an angle, two sides and an angle. But it can't just be any two sides and an angle. This is side angle side. Side, then followed by an angle, then side. This guy right here, this is angle side side. Angle side side. Not okay. Don't write this on your paper. Okay, this is not a valid theorem. Okay, we want SAS. We want the angle to be the included angle, and this is how you can remember that, because this is pretty memorable. Okay, number two, same idea. Is there enough information to prove that these two triangles are congruent? Well, I got a side, an included angle, and a side. I got a side, an included angle, and a side. Cool. Sounds good. So yeah, these are congruent. Congruent by SAS. Okay. Again, side angle side right now is the minimum information that we need to say that two triangles are congruent. If I have a fixed side, a fixed angle, and then another fixed side, there's only one way to complete this triangle. And this has the same situation, right? It's flipped over and spun around a little bit, but this is still the same length side, connected by the same angle. So there's only one other way to finish it. This guy would have to be congruent to this guy, and these angles would have to have corresponding congruent angles. That's how that works. But be careful of this, okay? All right, in the next few here, what I want to show you is sometimes you can use other pieces of information, other theorems, other postulates to help you finish getting the information that you need. Okay, so let's take a look at 3 and 4 for a second. Okay, now if you look at this, you'll see that there's two sides, right? You got a side congruent to a side and a side congruent to a side. So you might be thinking like, oh, there's obviously not enough information here, right? Because we don't have any other angles. Or do we? Okay, so what I want you to think about, go back in your mind and think about, what do we call these kind of angles? If you recall, these are called vertical angles. Right? These two lines, when they intersect, the ones that are like opposite of each other, they're called vertical angles. And there's a vertical angle congruence theorem, right? If two angles are vertical angles, we know they're congruent. So we have some more information now. We have more information than we did before because we used a different theorem. And this says, list any other relevant theorems or postulates. So the vertical angles theorem can get us another piece of information. Now with that piece of information, now do we have enough? Well, let's see. We got side, angle, side, and then we got angle side side, right? We got this situation, which is not what we want, right? Now, if we had this marked, this side and this side were congruent, then we'd be like, yeah, too, no problem. Just for the sake of argument, right? If we had these two, this one congruent to this one, then you'd be like, yeah, side angle side, side angle side, and you could use that vertical angles theorem to say that these are congruent. But that's not the case, right? We can still use the vertical angles theorem, that's fine. That's no biggie. We can still say these two angles are congruent, that's fine. The problem is we can't use SAS to say the triangles are congruent, because this is not SAS. This is ASS, okay? So don't use that. You can use your head, but you can't use your ASS. All right, so this is not enough information. Notice this is a similar setup, okay? And you can use a similar theorem on here, and the conclusion that you might reach might be different, but this is kind of a similar situation. I just want you to think about this and remember that if we were going to use this, we would have called this, we would have said not enough information, or we would have said they're congruent when we would have used vertical angles congruence theorem on this one, if we could have said they're congruent. Now, obviously, we said there was not enough information, even with that extra angle that we got, so we wouldn't really list this in this case. But if we did use that, which you may use over here, hint, hint, you would list that out, okay? Okay, we're going to do a couple more, and then I'll let you guys practice on this stuff. Okay, another scenario that you might see is scenarios like 5 and 6, when these triangles share a side, okay? So in number 3 and 4, you're going to use the vertical angles congruence theorem to give you more information. There's another thing that we can use here, because if you like separated this, you have this triangle, right? And then you have this triangle, but they share this side. And so what we know is that these triangles have another congruent side. Not only is this side congruent to this side, but we know that this side is congruent to itself. So if we split the triangles up, they would both have that piece, right? So let me just redraw them real quick. Just be kind of a sketch. Not perfect. But if we separate it, we'd have this one, and right angle, and then this one, and congruent to this one. And so we'd have side angle side, right? Side angle side. So this means that they're right angles, and we know that all right angles are congruent to each other. It's one of Euclid's postulates. But we also have this property that any segment is congruent to itself. And if you remember, having something congruent to itself is called the reflexive property. So we know that segment AB has to be congruent to itself. That's one of the things we proved before. Okay, so that idea that any segment or any angle is congruent to itself is the reflexive property of congruence. So the reflexive property of congruence allows us to say that, hey, there's not just this side and this side congruent, there's this side congruent to itself. So in these two triangles that we're looking at, we got side, angle, side, side, angle, side. You could also say, how do we know that these are congruent? Well, they're both right angles, so that's pretty obvious. They're both congruent. If you wanted to go one step further, you could say Euclid's fourth says that all right angles are congruent. So are these congruent by side, angle, side? Yes, they are. We had to do a little thinking to get that, but yeah, we have side, angle, side by the reflexive property of congruence. Okay, similar idea here, right? Now you got to make sure that the angles and sides match up the way they're supposed to. Make sure that you don't have, they have SAS, not something else. But you can say that in these two triangles, this side is congruent to itself using the reflexive property of equality. Is that enough? That's for you to decide. Okay. All right, one more here. In number 7, this is kind of a cool one too. So when you're looking at this guy and you see these two triangles, you'll notice, okay, I got a side congruent to a side. Is that it? Like, do I have anything else? Okay, well, if you remember what these guys mean, these guys mean parallel, right? That little arrow. So this dash, this tick mark, means these guys are congruent to each other. These arrows mean that they are parallel to each other. So what we have here, just to kind of extend this out here, is we have parallel lines cut by a transversal. And there's a whole bunch of stuff that we get with parallel lines cut by a transversal. One of the things we get is alternate interior angles. So check this out. That guy has to be congruent to that guy. Why? Because of the alternate interior angles theorem. We have two parallel lines cut by a transversal, which means that this guy and this guy are alternate interior angles. They're congruent. So if we use alt int angles theorem, we're going to get the extra angle that we need. Okay. Also, we have the reflexive property saying, hey, this triangle here is sharing a side with the white triangle here. They're both using this side. They both have that side. So check it out. This side's congruent to this side, check. This angle's congruent to this angle, check. This side's congruent to itself, check. So these two triangles have a side, an included angle, and a side that are congruent to each other, which means, yep, these are congruent by SAS. Let's go ahead and add reflexive property because we use that too. Reflexive prop of congruence, right? Any segment is congruent to itself, any angle is congruent to itself. Okay, so that's going to set you up for the rest of these. Use alternate interior angles, use reflexive property, use vertical angles to give you more information. Now, once you have that information, you still might not have congruent triangles. You still have to decide based on where the angles and where the sides are and what position they're in. But with that extra information, you may be able to say that you have congruent triangles or not. That's your task for the rest of this page.